Hello and welcome to my channel. Today we will see some amazing facts and mysteries behind black holes. So without any delay, let's get started. As we are talking about black holes, so the first question that came in our mind is, what is a black hole? So a black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying. Because no light can get out, people can't see black holes. They are invisible. Space telescopes with special tools can help find black holes. The special tools can see how stars that are very close to black holes act differently than other stars because of their intense gravitational pull. The first modern solution of general relativity that would characterize a black hole was found by Karl Schwarzschild in 1916, and its interpretation as a region of space from which nothing can escape. Black holes were long considered a mathematical curiosity. It was not until the 1960s that theoretical work showed they were a generic prediction of general relativity. Now let's talk about the size of the black hole. Black holes can be big or small. Scientists think the smallest black holes are as small as just one atom. These black holes are very tiny but have the mass of a large mountain. Another kind of black hole is called stellar mass black hole. Its mass can be up to 20 times more than the mass of the Sun. There may be many stellar mass black holes in Earth's galaxy. Earth's galaxy is called the Milky Way. The largest black holes are called supermassive black holes. These black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. It has a mass equal to about 4 million suns and would fit inside a very large ball that could hold a few million Earths. Black holes are really very simple as they have just two main parts, the event horizon and the singularity. The event horizon is the outer limit of the black hole. It is the closest thing a black hole has to a surface, but it's not a physical surface, it's an invisible bubble in space. The event horizon is the point of no return. Nothing can escape a black hole once it crosses the event horizon, and we can never see what happens inside it. However, using maths we can get an idea of what it might be like. The singularity lies right at the heart of the black hole. It is in this tiny spot that the entire mass of the black hole is contained. Anything that falls into the black hole is eventually crushed onto the singularity. How a black hole can pack such huge amounts of matter into such a tiny space is a mystery. To fully understand the singularity, scientists will need to combine two famous theories of the universe, the general theory of relativity, that explains the very large, and quantum theory, that explains the very small. The greater the mass hidden inside the singularity, the larger the event horizon. A stellar black hole with the mass of 5 suns has an event horizon around 30 kilometers wide, about the size of Ballarat. Supermassive black holes, with 1 billion times the mass of the Sun, have event horizons that are 3 billion km wide or about as large as the orbit of Uranus. Scientists believe that stellar mass black holes are made when the center of a very big star falls in upon itself, or collapses. When this happens, it causes a supernova. A supernova is an exploding star that blasts part of the star into space. Gravitational collapse occurs when an object's internal pressure is insufficient to resist the object's own gravity. For stars, this usually occurs either because a star has too little fuel left to maintain its temperature through stellar nucleosynthesis, or because a star that would have been stable receives extra matter in a way that does not raise its core temperature. In either case, the star's temperature is no longer high enough to prevent it from collapsing under its own weight. After a black hole has formed, it can continue to grow by absorbing mass from its surroundings. By absorbing other stars and merging with other black holes, supermassive black holes of millions of solar masses may form. There is consensus that supermassive black holes exist in the centers of most galaxies. Presence of a black hole can be inferred through its interaction with other matter and with electromagnetic radiation such as visible light. Matter that falls onto a black hole can form an external accretion disk heated by friction, forming quasars, some of the brightest objects in the universe. Stars passing too close to a supermassive black hole can be shred into streamers that shine very brightly before being swallowed. If there are other stars orbiting a black hole, their orbits can be used to determine the black hole's mass and location. Such observations can be used to exclude possible alternatives such as neutron stars. In this way, astronomers have identified numerous stellar black hole candidates in binary systems. and established that the radio source known as Sagittarius A, at the core of the Milky Way galaxy, contains a supermassive black hole of about 4.3 million solar masses. On April 10, 2019, the first direct image of a black hole and its vicinity was published, following observations made by the Event Horizon Telescope in 2017 of the supermassive black hole in Messier 87's galactic center. In March 2021, the EHD collaboration presented, for the first time, a polarized-based image of the black hole which may help better reveal the forces giving rise to quasars. This image that you are seeing behind me is the supermassive black hole at the core of supergiant elliptical galaxy Messier 87, with a mass about 7 billion times that of the Sun, as depicted in the first false color image in radio waves released by the Event Horizon Telescope, April 10, 2019. Visible are the crescent-shaped emission ring and central shadow, which are gravitationally magnified views of the black hole's photon ring and the photon capture zone of its event horizon. The crescent shape arises from the black hole's rotation and relativistic beaming. The shadow is about 2.6 times the diameter of the event horizon. In 1970s, astrophysicist Stephen Hawking discovered something remarkable. Through a strange and not yet completely understood interaction between the boundary of a black hole, known as the event horizon, and the quantum fields that make up reality, black holes can slowly evaporate. So they're not entirely black. They do give off a little bit of energy, which causes them to lose mass. It's not much since a typical black hole will emit only one particle every year, but it's not nothing. Over time they shrink down to nothing and simply pop away in a flash of energy. It's not exactly fast. A good-sized black hole, say, a few times more massive than the Sun, will take about 10 to the power of 100 years, or also known as Google years, to eventually evaporate through this process, known as Hawking radiation. Considering that the universe is only 13.8 billion years old right now, we've got to wait just a little bit before black holes go away. But go away they will. In the far future, after every star has lived and died, after every planet has dissolved, and after every galaxy has torn itself apart, the only thing remaining in the universe will be the black holes. And eventually those too will go out, leaving behind a shower of subatomic particles to aimlessly float through an empty and desolate cosmos. I know it sounds depressing, but like I said, we've got a little bit of time before that happens. So friends, this is it for now. If you liked the video, then don't forget to like and subscribe and share it with your friends. We'll try our best to bring you such amazing facts about the universe. Till then, take care and goodbye.